Hello student, last lecture I given the assignment to you and think about the assignment. Is it true or false? Just verify. Log 2 plus log 3 is log 5. Is it false? Because 2 3s are 6. Log 4 plus log 3 is log 12. Yes, it is right because 4 3s are 12. We know that log m plus log n is log m into n. Log 10 plus log 10 is log 100. Is it true? Obviously. Because log m plus log n is log mn. 10 into 10, 100. Next, log 2 into log 3 is equal to log 6. It is false statement because in the laws of logarithm we have only log m plus log n is log mn only. So it is false. Log 3 square plus log 3 raised to minus 2 equal to 0. Why? Because we know that log m plus log n is log mn. We multiply 3 square into 3 raised to minus 2. That is how we derive. Then 2 minus 2 goes to 0. So 3 raised to 0, 1. And log of 1 is 0. Log 5 upon 3 is equal to log 5 to the upon log 3. Base are same, so here we have to use the change of base rule, but it is not applicable for 5 upon 3. It is in the form of suppose log 5 to the base 3, then it is applicable. Be sure about this thing. Here we have to think log 8 to the base log 2 is equal to log 4. It is not possible because log 8 to the base e to the log 2 to the base e is exactly log 8 to the base 2. It is false. These are both are the examples of change of base rule. So in this assignment we get clear idea about the examples that we have to solve and think about the calculation we have to improve. My one more question is, what is the solution of 5 raised to x equal to 4? Is it x equal to log 4 to the base e to the base 5? Log x 4 upon log 5 to the base e, or x equal to log 4 to the base e log 5 to the base e, and the last one x equal to log 4 upon 5. These four options are right for this solution of this 5 raised to x equal to 4. It is your homework question. You have to must note down all these things and think about that. It is very interesting. Here are several examples with log base 5. How it is possible? Log 5 to the base 5 equal to 1. Sin 5 raised to 1, 5. Log 25 to the base 5 is equal to 2. Means 5 raised to 2 is equal to 25. Log 125 to the base 5 is equal to 3. Since 5 raised to 3 is 125. Log 625 to the base 5 is equal to 4. We know that 5 raised to 4 is 625. So I give the statement that is the logarithmic function is exponent form, because we have to interchange these in the form of the exponent. We get exactly idea about log and the exponent form are must be equal. That is very interesting topic in today's lecture. Be particular about and be think about this statement, that is the logarithm is an exponent. It is interesting, na? Yes, student. Be prepared for all these things. Let us start from some our rule to revise once again. Rule 1, log m into n to the base b means any base. Log m to the base b plus log n to the base b. That is the which law? Product law. Yes, that's right. Rule 2, log m upon n to the base b is equal to log m to the base b minus log n to the base b. That is which law? Yes, right. That is quotient law. Okay. Third rule, log to the base b m raised to k is equal to k log of m to the base b. Here I have changed the alphabet something in the form of but. remind that it is the which law? Power function law. This k gets its side and log remains same. And base is anything. Uh, Rule number 4, that is more important. Log of a one number is any base is always 0. Log Rule number 5, log b to the base b is always 1. Any number have the same base is always 1. For example, log 3 to the base 3, what? 1. That is exactly. That's the important thing they given, that log b raised to k is equal to k. What is that? K goes this side and log b to the base b is 1. That's why we derive answer is k. Okay. Here they mention the opposite properties applicable for b raised to k. Be sure about that thing. Rule number 7, very important. B raised to log to the base b, k is equal to 1. K. Most probably k symbol is there. K is in a general term. How? Suppose 10 log to the base 10 k. These will all get cancelled. We derive the k. Suppose get 3. Answer is 3. Always reminded. Where b greater than 1 and m and r and k may be any real numbers, but m and n must be positive. In a logarithmic, all the chapters we have to take the example based on function or number always are positive. Be clear about time. Log in bracket negative term is not possible always. Some fun part explained from the graph also. These have application logarithmic function in chemistry also, or in a mathematical equation also. How? Let's try. From these diagram, what you see? I think we know that this is y-axis. This one is x-axis. This start from 1, 2, 3 up to last. This side -1, -2, -3 up to last. This side y-axis also have the 1, 2, 3 up to last. Here -1, -2, -3 up to last. Just I give the statement that logarithmic function is always the exponential function, but exponent and logarithm are inverse. That is the main statement in pie graph. How? We know that if I start from e raised to 0 is always what? 1. So our first point is 0, 1. And we reach up to 0, 1, e raised to 1 up to these, between two these values 0 0.21, 0 0.123, 0 0.144. So it is the graph. Now start from the our logarithmic function. We know that log of 1 is always 0. So that is why first point is 1, 0. Log of e to the base e is always 1. So we derive the 1 here and we log e is the function. Okay. So this graph is symmetric. From this side to this side, this quadrant is lies, and this side to this side lies. Be sure about that thing. This statement is that f inverse, that is ln x, and log to the base e of x are inverse function of each other. It is very interesting, no? By graphical way, we better understand the exponential function e raised to x is always same as the logarithmic function log x, and most probably ln gives the base is always e. Be reminded and be particular about this thing. Are you understand by this graph? I once again explain for you. Just we know that exponential function is denoted by e raised to x and logarithmic function is obviously log x. Suppose I put x equal to 0, so e raised to 0 is always 1. So I put x and here is y, so 1. So we derive the first value is 1. We reach up to infinite value up to what? 1 comma e, because e raised to 1 remain as a e. Okay. Now let's just start from the log function. Log of 1 is always 0. So that's why our x value is 1, y value is 0. Log of e to the base e is always 1. So we reach up to this. These are exactly symmetric graphs And that's why we give the statement that the logarithmic and exponent are inverse function of each other. You understand? Better understand all the concept. Now let us move to some interesting fact of logarithmic chapter. What are they? Log of negative number is undefined. We know that log minus 6 is undefined. In calculator you also use, and let us try about find log minus 16. You get the mathematical error. Let us check in your calculator. Log of 0 is undefined. That is also, you may use the calculator and solve find log 0. What error you got there? Log 1 is always 0. If two logarithm have different base, such as log x to the base 3, log a to the base 4, the problem is not feasible to solve by hand. Be particular about that. A change of base rule must be, these number must be same. These number are different, may be considered, but base are always same. That is the summary of all logarithm chapter, that negative numbers log is not defined, log of 0 is also not defined, log of 1 is always 0, and in the change of base rule log must have the base same. These different numbers may be considered. One more property, I give the statement by this PPT, that is log a raised to b. I shift b log a. Logarithm are exponent. How? X raised to a into b is equal to x raised to a into b. Think about that. What an interesting topic I discuss today's lecture. These are useful in a application of logarithm. From this picture, what are you to see, student, or what something is missing? Let us check. Exponential and logarithmic properties, which check log m into n, log b to the of m, log b n. Yes, we know that log m into n is log m plus log n. Log ln base is e, so we give ln mn is equal to ln m plus ln n. Quotient log to the base b of m upon n is log m to the base b minus log n to the base b. Ln m upon n is obviously ln m minus ln n. Power, that is very useful laws of logarithm, that is log m raised to k is k log of m to the base b, ln m raised to k ln of m. That means properties are most useful in a log also and ln also. That means log have base e and all this thing. Inverse we have to check. Log b to the x of b is x. B log x to the base b is x. Ln e raised to x is x. E raised to ln of x is equal to x. Log 10 to the raised to x equal to x, and 10 raised to log to the base 10 of x equal to x. These are very useful in our above topics in mathematics 2, that is derivative and integration, which must be studied. All these properties there also. Okay, so always remind these properties. These are very useful in each type of logarithm chapter and in your physics, chemistry and applied mathematics in future. Exponent part, b raised to x equal to a. Then we convert log a to the base b is equal to x. Change of base rule, that is very important. Log m to the base b is log m upon log b, and base must be same. Here they take a. For calculator, log m to the base b or log m to the base b, ln to the base b, log give the what base? Any base or 10 base most probably, and ln is always have the base e. Just we take the graph of that thing here. This graph and this graph is same. What they given? Y is equal to bx. Inverse to y is equal to log h to the base b. It is exactly exponent and logarithm.